Imagine diving nearly 4,000 meters, 13,000 feet, below the ocean's surface. At this depth, there is no sunlight, the temperature is just above freezing, and the pressure is hundreds of times greater than at sea level. For decades, scientists believed that oxygen could only be produced through photosynthesis, a process requiring sunlight. Plants, algae, and microscopic phytoplankton capture solar energy and release oxygen, making Earth's atmosphere breathable. Because sunlight cannot reach the deep ocean, researchers assumed that oxygen found there had simply drifted down from the surface over long periods. But in 2024, an astonishing scientific discovery challenged that assumption. Researchers studying the Clarion Clipperton Zone in the Pacific Ocean detected oxygen apparently being produced in complete darkness. This unexpected phenomenon was named dark oxygen, and it has become one of the most fascinating mysteries in modern ocean science. If confirmed, this discovery could reshape our understanding of Earth's oceans, the origins of life, and even the possibility of life on distant planets. The discovery began during deep-sea expeditions investigating the mineral-rich seabed. Scientists deployed highly sensitive instruments designed to measure oxygen concentrations around the ocean floor. Their expectation was straightforward. Oxygen levels should slowly decrease as microorganisms consumed it. Instead, they observed something completely unexpected. In certain locations, oxygen levels were actually increasing. At first, the researchers suspected faulty equipment. Every sensor was recalibrated, every measurement repeated, and new experiments conducted using different instruments. Yet the results remained consistent. Somehow, oxygen was appearing where sunlight had never reached. The scientific community responded with both excitement and skepticism. Extraordinary discoveries require extraordinary evidence, and researchers immediately began searching for an explanation. To understand why this finding is so surprising, we first need to understand how oxygen is normally produced. Nearly all oxygen on Earth originates through photosynthesis. Green plants on land and microscopic algae in the oceans use sunlight to split water molecules into hydrogen and oxygen. This process has sustained Earth's atmosphere for billions of years. Without sunlight, photosynthesis simply cannot occur. That is why scientists believed oxygen production in total darkness was impossible. Deep-sea ecosystems were thought to survive by consuming oxygen transported from the upper ocean, not by generating it themselves. The new observations challenge one of the most fundamental assumptions in biology. The leading explanation centers on mysterious objects scattered across the deep ocean floor known as polymetallic nodules. These black, potato-sized rocks contain valuable metals including manganese, nickel, cobalt, copper, and iron. They grow incredibly slowly, often taking millions of years to reach their present size. For decades, they were viewed mainly as potential mining resources for batteries and renewable energy technologies. But recent research suggests these nodules may possess another remarkable property. Scientists believe they could function like tiny natural batteries. Because they contain different metals, slight electrical voltage differences may form across their surfaces. If these electrical currents become strong enough, they might split water molecules into hydrogen and oxygen through a process called electrolysis, the same principle humans use in laboratories to generate oxygen using electricity. If this hypothesis proves correct, the ocean floor itself may be quietly producing oxygen without any sunlight. However, not every scientist agrees with this interpretation. Some researchers argue that the observed oxygen increases may result from previously unknown chemical reactions rather than electrolysis. Others suggest hidden microbial communities might be responsible. Deep-sea microorganisms are among the least understood life forms on Earth. Many survive near hydrothermal vents by obtaining energy from chemicals instead of sunlight, a process called chemosynthesis. Although chemosynthesis does not directly produce oxygen, scientists cannot yet rule out the possibility that unknown biological processes are involved. There is also the possibility that experimental conditions unintentionally influence the measurements. Because this discovery is so revolutionary, laboratories around the world are now conducting independent studies to determine whether dark oxygen production is real, how widespread it might be, and what mechanisms drive it. The implications extend far beyond oceanography. If oxygen can be produced naturally in complete darkness, scientists may need to rethink how life first evolved on Earth. Traditional theories suggest that oxygen-rich environments became common only after photosynthetic organisms evolved billions of years ago. But if localized oxygen production existed deep beneath the oceans long before widespread photosynthesis, ancient microbial life may have encountered oxygen much earlier than previously believed. This possibility could change our understanding of evolution, biological adaptation, and the history of Earth's atmosphere. The discovery also has enormous significance for the search for extraterrestrial life. For years, astronomers have considered atmospheric oxygen one of the strongest indicators that life may exist on another planet. But if oxygen can also be generated through natural geological or electrochemical processes without biology or sunlight, scientists will need to interpret future observations more carefully. Ocean worlds, such as Jupiter's moon Europa and Saturn's moon Enceladus, hide vast liquid oceans beneath thick layers of ice. Sunlight never reaches these hidden seas, yet they may contain minerals and chemical conditions similar to Earth's deep ocean. If dark oxygen can form naturally there, it could provide an energy source capable of supporting microbial ecosystems. This possibility makes the search for alien life even more exciting and far more complex. There is another important consequence involving deep-sea mining. The Clarion Clipperton Zone contains one of the world's largest reserves of polymetallic nodules, making it a major target for mining companies seeking metals essential for electric vehicle batteries and renewable energy infrastructure. If these nodules are confirmed to play a role in oxygen production or help sustain fragile deep-sea ecosystems, removing them could have unforeseen environmental consequences. Deep-sea habitats recover extremely slowly, and disturbing them might affect species that scientists have not even discovered yet. As a result, this mystery has become part of a growing debate about whether humanity should mine the deep ocean before fully understanding how these ecosystems function. One of the most fascinating aspects of this discovery is how it reminds us that our own planet remains largely unexplored. More than 70% of Earth's surface is covered by oceans, yet scientists estimate that much of the deep seafloor has never been directly observed. We know the surfaces of Mars and the Moon in greater detail than many regions of Earth's deepest oceans. Every new expedition reveals species, geological formations, and chemical processes unlike anything previously known. The dark oxygen mystery is another reminder that our greatest scientific surprises may still lie hidden beneath the waves. Today, the scientific community remains cautious. Researchers emphasize that the discovery is still under investigation and that additional evidence is essential before rewriting biology textbooks. Independent experiments, new deep-sea missions, and improved instruments will determine whether dark oxygen truly exists as a widespread natural phenomenon or whether another explanation eventually emerges. This careful scientific process, testing, questioning, and verifying extraordinary claims is exactly how major breakthroughs are made. Whether dark oxygen turns out to be the result of natural electrolysis, unknown microorganisms, or something we've never imagined before, one thing is certain: our journey to understand the deep ocean has only just begun. Hidden nearly 4 kilometers beneath the waves, in complete darkness, nature may still be writing chapters of Earth's story that we have yet to read. If you enjoyed exploring this incredible mystery, don't forget to hit the like button, subscribe to the channel, and turn on the notification bell so you never miss our next journey into the world's greatest scientific mysteries. What do you think? Is dark oxygen created by natural electrolysis, unknown microorganisms, or something we've never imagined before? Share your thoughts in the comments below. I'd love to hear your theories. Thanks for watching, and I'll see you in the next adventure.